Hi there, it's Warno. After watching numerous repair videos from Adam on YouTube channel One Circuit, I was very impressed with his troubleshooting techniques, and it reminded me that I kind of enjoy doing that. So it's inspired me to take a look at some of the repair work that's been sitting that I haven't done anything with for a long time. And I have a Tempest machine, and I didn't have a PCB for it, and I bought one on eBay some time ago as untested, which presumably means does not work. And I've been trying to figure out how to get that going. So far, the only physical damage or anything physically broken that I could find was some adjustment pots in the vector outputs. And I have replaced those with some newer potentiometers. And as far as I know, those are working as they should. I have it powered up just using a test power supply and a bunch of alligator clips. Not the most elegant, but when you don't have a wiring harness set up for each game that you want to try to fix, sometimes that's good enough. I have it powered up, and I have the vector outputs connected to my trusty old Tektronix 465, and you can see that it's producing, in the XY mode, it's producing an output, but everything seems to be kind of jammed up against the top and bottom on the Y. So I think there's something wrong with the Y output, and I was going to start taking a look at that. Maybe the digital to analog converters have some missing bits, or there's just some bad bits being put into the chain somewhere. I've got to go back and look at how the vector generator works on Tempest to try to figure out where to go next. Okay, this is the digital to analog converter for the Y axis. Going to the monitor, this takes the numeric value coming from the vector generator, turns it into an analog signal that drives the beam on the monitor. And on the left, it's got pins 2 through 11 are getting a 9-bit signal from the vector generator, telling it what location on the y-axis to output. And if I test those pins with a logic probe on the actual chip, this is the chip on the board itself. If I test with the logic probe, starting with the highest bit, the logic probe is making a stream of beeps, which indicates a pulse condition. And that means that the data is changing rapidly on that line. So that tells you that the signal going there, it is actually getting data on that bit. Not necessarily the right data, but at least you know it's getting data. And I check all of the other bits in the sequence, and they're all good, or at least they're all producing data, except the lowest bit, which is just coming up as not connected or no signal. So it's not being driven by anything. So it's possible either that bit just doesn't do anything in this case, or it's supposed to be driven and it's not being driven. Well, I found where that signal comes from. It comes from the vector generator data shifter, which takes some bits being generated by the vector generator, and it latches them to send out to the digital to analog converter section. I discovered that this chip, H5, is the one that's outputting DVY3, and I measured it, and it was outputting just fine. So it seemed as if either the schematics are wrong, or there's something wrong with getting the signal from one end of the board to the other. So I took the board set stack apart and found where H5 starts and followed where the signal went. And lo and behold, there's a whole line of traces that have been damaged while this board was sitting on the shelf. So apparently this board was not stored properly by any stretch of the imagination, given that there were broken pots on the top and these gouges on the bottom. So now I've got to go through and figure out which of these connections need to be repaired. I'm guessing a lot of them are just scratched on the surface and they're still okay, but some of them apparently are broken, so we need to clean those up. So now basically what I have to do is follow each of these traces that looks like it might be damaged and check the continuity on both sides using my diode continuity check mode on my meter. So the first one's good, second one's good, third one good. Follow that one. Aha, that one, and that is pin 15 on H5. So that's the one that wasn't working. Yeah, definitely has a bad trace. The rest of these look like they're probably okay, but let me give them a quick check. So what I will do is solder a jumper wire for the one that's broken, and probably just put some solder over the bare copper on the other ones. Okay, soldering is done, and if you look at the board, I basically just tinned over most of the scraped connections with some solder just to kind of strengthen them and protect them. And the one that was broken, instead of running a long jumper wire from one end of the connection to the other, I'll sometimes do this. I just took a short piece of like the end of a resistor lead or something, and I just made a bridge across the broken part of the trace. As long as you get it firmly attached on both sides, this works really well, and you don't end up with wires going all over the place. This was only one connection, and it had enough space around it, so it seemed okay to do that. Well, we fixed a problem, but not the only problem. All of the bits are now getting to the Y DAC, which is good, but we are still getting this kind of slammed to the top and bottom pattern on this scope. And I'm not quite sure what's up with that, but I decided to hook up my digital scope to the output, and you can definitely see that the output is most of the time near the top or bottom of its range and occasionally right in the middle. And so it's possible that we're getting all of the bits for the DAC, but we're not getting the right bits for some reason, and there's a vector generator problem, or there's an analog problem of some sort in the output section. So what I want to do to test that is take a look at the output directly from the DAC. I connect directly to pin 18. If I look at that, I can see it's definitely using a wider range of values. So something is wrong between the DAC and the output. So let us investigate that a little bit further. Well, I guess one must inspect for physical damage very carefully, because I've just discovered that there's a capacitor C100 which is missing, but there are some components that aren't populated here. It's for a different version, I think, with a different DAC chip. But the C100, there's actually little bits of pin in the hole, so it's supposed to have a part, and it doesn't have a part. So let's see what happens when we reinstall that capacitor. And it looks like this capacitor is in the feedback loop here of an op-amp circuit on the output of the DAC. So that's probably a fairly important piece of the circuit, and it's calling for a 0.047 microfarad polycarbonate capacitor, which is a kind of unusual one, so I'm not sure why they felt they needed a critical type of part for that. Now, the X channel has the same capacitor, and that is this one here. It's this one right here. So I'm going to see if I have anything similar to that. We'll plug that in there and see how it goes. Okay, I've installed cap in the location that had the broken off capacitor, and I didn't have the fancy polycarbonate type. I just used I guess this is like a polyester film capacitor or something. Anyway, it's the right value, so hopefully it will do the job. And if I take a look at what the screen is doing, it is now recognizable as Tempest. So this is definitely progress. Unfortunately, it looks as though I have some kind of a Mathbox problem because the text and everything is coming up as it should, but the actual vector lines for the play field don't seem to be coming up in the right locations. That's supposed to be one of the normal patterns, and it's coming up just with odd things in different directions, and the enemies are jumping around in various directions, which they shouldn't be doing. I've also had some cases where the watchdog would trip, and it would just sit there and reset itself. And let's see if I can make that happen. Yeah, there's. This is what it was doing, where it starts to run, and then the watchdog immediately reboots it, so it just sits there in a loop like that. So there's some kind of bad connection, because if I push on the ROMs or hold the board at the right angle or whatever, it starts to work again. So there's still something intermittent. Hopefully I don't have a Mathbox problem and it's just a flaky ROM or something like that. So I'm going to reseat the ROMs and see what things look like after that. Well, at this point, I'm suspecting bad solder joints on the connector that goes between the two boards. This is the auxiliary PCB, and I don't know if you can see it, but some of the solder joints have a little bit of kind of a ring around them, like this first one on the end. If you look at it, you can see that the solder isn't actually quite contacting the pin. And there's a few more that are kind of like that. So what I'm going to do is flow some fresh solder onto all of these pins, probably on both boards, just for good measure. And we'll see if that helps. Also of note, both boards have power LEDs, and both of them are not working. I actually replaced the one on the main board. I didn't think too much of it, so I just replaced it. But now I've noticed that the auxiliary board has the same LED, and it doesn't work as well. And it's just connected right to the 5-volt rail, so that kind of makes me think this board was probably plugged into a power supply that was putting out too much power, which is usually pretty bad for the rest of the board, but it's close enough to working that hopefully nothing major was damaged. Okay, I've reflowed the solder on the connectors on the two boards, and there were some pins on the main board that looked a little bit suspect too. So hopefully that will take care of our problem, because the vector calculations are done on the auxiliary board, and if the connections between that board and the main board aren't working correctly, then you're going to get strange vectors. So hopefully that's all it is, and not something with the vector generators themselves. Well, that seems to have eliminated the flakiness. That it isn't resetting with the watchdog and wiggling the connections and things. Doesn't make it blank out or do strange things, get unstable anymore. But the vectors for the playfield are still all scrambled. So I think I may have some kind of a Mathbox problem, unfortunately. Well, what I'm doing now is the simplest thing I can think of to try to test the Mathbox, which is to take the 4 bit slice chips in it and sort of rotate them and see if rotate meaning not turn the chips around, but move the positions of each chip. So we'll see if it behaves any differently after doing that. Well, it might be different, but I wouldn't call it better. So I'm not sure exactly where that leaves me. Maybe I'll see if I can get the built-in self-test diagnostics to tell me something. And I don't have any controls set up here, so I can't really run the built-in diagnostics. So I think I'm going to try it, plugging it into the cabinet and running it there and seeing if it behaves any differently and seeing what the self-tests have to say. Okay, I've plugged it into the cabinet and I've learned something very interesting. It definitely does have the scrambled vectors, but there are also sounds being generated that aren't correct. So there shouldn't be any sound going on at all right now. And there definitely is sound, and it seems to correspond to what's being displayed on the screen. So the Mathbox chips and the sound chips, the Pokies, are on the same board. They're on the auxiliary board. And this is making me suspect some sort of address problem, so that it's not addressing the correct chip. So that means that the information getting to the Mathbox chips isn't correct, and the information getting to the sound chips isn't correct. So what I need to do is look for address lines that enable those chips to see if they're acting the way they're supposed to. I also decided to run the self-test now that I have the controls, and I'm getting Q and M on the display, and I believe the M means Mathbox error, and I'm not sure what the Q means, but I will look that up. Okay, I'm looking at the auxiliary board now, and I looked in the service manual, and the Q error code means the second sound chip, the second Poki, is having a failure of some sort. So I've got an error with the second Poki, and I've got a Mathbox error. So I'm guessing, based on the sounds that I was getting in the cabinet, that the second Poki is being addressed when it's not supposed to be. So I need to look up the pins for that and test to see if it's being addressed at the correct times or not. So according to the schematics, this is one of the Poki chips, and Poki 2 is the signal that goes to the chip enable, the chip select, and that's on pin 30. If I check pin 30, I'm not sure which Poki is which. 40. 30, okay, so that seems to be pulsing, so I suspect that one's fine. 40, 38, 38, 6, 5, 4, 3, 2, 1, 0. And that is a floating line on that chip select, so that means that Poki, it's indeterminate as to whether or not it will be selected at any given time. So now I got to trace back where that signal is coming from and figure out if we've got another bad trace on a circuit board that I didn't catch before, or if there's a problem with the IC that is latching, or that is making that select signal. So if I look at the schematics, that comes from the address decoder, and that's B5 is putting out Poki 1, Poki 2. And that's pins 4 and 5 of B5. Let's check B5. I'm going to check pins 3 and 4. 3 is pulsing. 4 is also pulsing. So it appears that there's a problem getting from that chip to that chip. So let's see if we can figure out, because I'm going to have to flip the board over for that. Well, I was looking at the wrong pins on the chip that was creating the Poki chip select lines. It's actually pins 4 and 5, not 3 and 4. But that doesn't really matter, because I just looked at the traces on the board once I saw there was a floating input to the Poki. And I discovered this nice little bit of damage. I don't know exactly what this would have been caused by, since it's just one little section, but it's definitely gouged out and definitely does not connect. So I'm going to fix that and see where we get. here's the repair wire for the broken trace. Decided to use an actual wire this time instead of just a small piece of component lead. It just seemed, I don't know, safer somehow on this one because there was such a big broken area. Okay, it's connected up. Let's fire it up and see what we get. Well, that looks pretty good. Certainly better. I'm not sure we've taken care of everything, though. Well, we're definitely getting actual shapes now instead of random things, and the enemies are coming up where they should. So I think I'm going to plug this back into the cabinet, see how it works. Well, things are definitely looking good. I think I know why the shapes didn't look quite right on the scope display. I think there's a linearity adjustment or something that I have to make so that the lines will converge properly. But the game itself is now working. And it's very difficult to play with one hand. But you get the idea. So now I just need to see if I can adjust those pots to get all the lines to converge. As a bonus, here's my Wells Gardner 6100 monitor in the Tempest. And in case you've never heard vector chatter, that was the Tempest intro logo as heard on the deflection coils, which act a little bit like a speaker. Okay, so we're not quite finished yet. I was trying to adjust the pots that make the lines line up correctly on the screen, and one of them was not doing anything, which is this one here, the Y bip. And I popped the knob off of it, and there's no wiper inside, so I don't quite understand how that can be, but clearly it's not doing what it needs to do, so I have to replace it. And it's a 200 ohm, which is kind of an unusual value. So I might have to put a slightly different one in, but it should still do the trick. So I put in a 2K instead of a 200 ohm, and basically that just means the control is going to have a very small range of adjustment, so you'll need to adjust it very carefully. But it shouldn't hurt anything. It's just going to be a little bit more touchy to adjust. Well, things are looking pretty good. My vectors are all lined up now. The only problem I seem to have is that the right side of the screen is a little bit narrower than the left side, so it kind of slopes inward towards the right. And I'm not sure if that's a monitor adjustment or if there's something with the pots on the board that I haven't got quite right yet. But I think I'm going to call this good enough for now. I hope you found this somewhat interesting. It's my first attempt at a repair video, so apologies for poor photography, etc. But it was interesting to give it a try. I hope you liked it. Thanks.